So we have a study that looked at latitude to explain our mortality rates from skin cancer. Data was collected in the 1950s from 49 states. Notice it does talk about 49 states, not 49 people. Okay. And it says mortality is the number of deaths per million people. Latitude is the degrees north at the center of the state. Okay, let's see. So A says pick all that apply. This is an example of. Now, before you look at these, I usually like to try and figure out what my answers would be before I look. Okay. First of all, if I'm looking, it looks like this would be a negative association. Okay, it's a negative slope, a negative correlation, a negative association. Whichever of those she wants to put on there, it's a negative something. Okay, so it looks like our choice here was negative relationship. You could also say negative slope, negative correlation. Also, notice how I said it was from each of the 49 states. It didn't look at individual people. It looked at the averages for each state. So that's going to make an ecological correlation because, again, it just looked at each state instead of individual people. We know that that always makes the correlation seem higher than it truly is because it's all averaged out. It makes it seem like points are closer to the line. If you looked at individual people, the points would seem farther away from the line. Then I look at the other choices. It's not a positive relationship. It's going down, so it can't be that one. Simpson's paradox is a different thing where you have like two different groups of people, and when you put them together, it seems like there's a different relationship than there really is. So like two negative slopes put together might become a positive or something like that. It's not Simpson's paradox. The last choice was a causal relationship. So that says, does latitude affect the mortality or does it cause it? It could maybe be a cause and effect. We don't really know that in our statistics. We don't like to say that it's cause and effect, so we're going to cross that off because we can't ever really say anything is causing something. We can just say on average. Okay, let's see. Then guess the correlation. I would say, well, we already said it's negative. It looks like the points are fairly close to the line. So if my choices are negative 0.8, negative 0.5, or negative 0.1, I would say probably negative 0.8 because it looks like they're fairly close to the line. Part C says, guess the average and standard deviation of latitude. Remember, this is one that the book loves to do because they want you to always remember that almost all or about 95% of data for anything you're talking about will be within 2 standard deviations of the average. Now that 95% applies more for a normal distribution. This might not be normal, so it might not be 95%. It might only be, say, 90% or maybe 85%. But almost all is going to be within that 2 standard deviations of the average. And we'll just still say 95% because you spent all semester memorizing that. So when I look at latitude, what I'm going to do to try and guess what the average and standard deviation will be is I'm just going to eyeball it and say, I think the average is somewhere about here. We're not expecting you to be super close. So for latitude, I'm going to guess the average is about, maybe say 39. Okay, that's just my guess. Now let's see, where am I going to say for my standard deviations? So when I do this, this is not an exact science. I don't expect you to get it exactly right. You're just trying to pick the closest multiple choice answer. Okay, so I don't want to include all of my points because it's almost all. So I might say like from here to say like here is most of my data. That was a pretty crooked line. You'll notice I just left off 1 or 2 because there's not tons of points. Maybe if there are tons of points, you leave off like 4 or 5. This is not exact. I'm sorry, I can't give you a better way to do it. So I'm going to guess that my data goes from about, say, maybe 32 to 47. Okay. Now remember, how far is it supposed to be? It's supposed to be within 2 standard deviations of the average. So if this is my average, then if I go over 1, this would be 1 standard deviation, and I go over another one, this would be 2 standard deviations. So how far do I have to go to get from the average to 2 standard deviations? There's different ways you can put this in your calculator. We said our average is about 39. So how far is it from 39 to 47? About 8. So to go from here to here is probably about 4. And to go from here to here is probably about 4. So it looks like my standard deviation would be about 4. That gets me from 39 up to 47. I also will look at it and say, well, like 47 minus 32 is equal to 15. So 15 divided by, so that's my total length from here to here. There should be 4 different sections. So if I divide it by 4, I'm going to get 3.75. So I'm going to guess my standard deviations are somewhere around like 4, 3.75. So I'm going to guess my SD is about 4. Again, this is not exact. You're just trying to get to the closest thing, whether you want to just draw it into 4 sections and try and eyeball it. If you want to go from the smallest to the biggest and divide by 4, because that's 4 total sections, you can do it any way you want. Okay, and we're just trying to get our closest guess. With the big thing, remembering almost all of our data, not all of the points, but almost all will be within 2 standard deviations of the average. So now let's try that exact same thing for mortality. So again, I'm going to kind of say like most of the points. So I'm going to say my bottom's about here. And I'm going to say my top is probably about here. I'm just kind of eyeballing it. My average is probably about here. So I'm going to say my average is about 165. And remember, most of our data should be within 2 standard deviations. So that means we start at our average and we go to 1 standard deviation and then we go to 2 standard deviations. So let's try and figure out how big that distance should be from here to here. So if we're saying this is like 165, then I have to get from 165 to 100. Or my top point up here is maybe about 220. So I might say like 220 minus my bottom of 100 is about 120, and it's divided into 4 total sections. So 120 divided by 4 equals about 30. So I'm guessing my SD is probably about 30. Again, I don't know what these are exactly. I'm just trying to get the closest answer. It's not a science. Okay, that's why we have computers to actually figure out for us exactly. I can tell you though, because I had the computer and I had the data set, that my actual average was 153. So I wasn't super close, but close enough I could get it on multiple choice. And the standard deviation was 33. So guessing 30, I was pretty close enough to get it on the test.